Now to the next speaker, which is Daniel Norman, and he's going to show us how to use Prisma with MongoDB. It's something new, and I think there are many changes. Are they? Because I've
Hi,
been receiving
Aris.
some.
First of all, thank you for the warm welcome. And yes, there are some changes as we're continuously evolving the MongoDB connector, but I'll definitely get into that.
Thank you. I'm looking forward to hear your talk and find out more about those changes.
Let's do it. Okay, let me just share my screen. And it looks like we have some video lag. Let's see if we can get that. Okay, that should work. So, hi all. Let me just get going here. Make sure it's all running. Great. So the internet connection is fine. Hi, welcome to Making MongoDB Type Safe with Prisma. I think that Peter's talk did a really nice job of showing a lot of the ideas of Prisma in the context of a full stack app. And in this talk, I hope to sort of take a step back and give the sort of broader picture of what it means to use Prisma, what is type safety, and how does that fit in with MongoDB. And I also invite all of you who are watching to send your questions. You can just drop them as a comment in the live chat on YouTube, and I'd be happy to get to those at the end of the talk. So I'd like to begin this talk with a question, and that is, what tools and practices make you productive as an application developer? And I will share a bit of a personal anecdote that I think might inform a lot of the ideas that I want to present in this talk. So about 11 years ago, I started a job as a software developer for a company that was doing web crawling. And the main application that I was working on had been written in PHP and used Postgres as the database. And this application had evolved over the years. There was a lot of spaghetti code in it, but it worked. And we were using SVN. This is prior to us adopting Git at the time, and there were no tests. The backend logic was heavily coupled with templating and front-end logic. We didn't actually have a migration system for the database, so all schema changes were carried out directly on the database, and there was no real way to correlate schema changes with the application code. Nonetheless, I felt very productive. I'd write SQL queries, I'd write business logic, and just pump data to the front end. And the main problem there was that I had no guardrails, and often mysterious bugs would pop up after deployment. And so counting on sort of the amount of time that I spent debugging, I was probably not as productive as I thought. Debugging was slow because I would log data as it flowed through my local development environment until I found the root cause. And in hindsight, this is no surprise. Data was flowing across 3 different runtimes, from the database to the PHP runtime and then to the browser. And each runtime had its own representation for the data, and there were no real tools to sort of prevent from mishandling of data. And this was 11 years ago, and a lot has changed since in the software development world with new tools and practices that really focus on preventing such errors. And so in today's talk, we will look at these challenges when working with MongoDB's flexible schema, some of the existing solutions, and finally at Prisma's approach to these challenges. In the first part, we'll explore these practices that increase productivity and introduce some concepts such as the feedback loop. In the second part, we'll delve deeper into the different approaches to schemas in MongoDB. And third, in the final part, we will look at how Prisma makes MongoDB access type safe and increases productivity. So upon reflection on my adventures and misadventures in the last 10 years of building these data-intensive applications, a couple of noteworthy practices came to mind when it comes to productivity. The first is testing, which really allows you to verify the correct behavior of your software, of the software that you're building, and that includes, unit tests, end-to-end tests, load tests. The second is automation, which reduces toil by automating the repetitive aspects of the development lifecycle. And so that, for example, that might include build processes, tests, releases, and deployments that are often automated by your CI/CD pipeline. And finally, type safety, which is a broad term used in the context of statically typed languages like TypeScript and Go. But the idea with type safety is that by defining types in your application code, you can detect these type errors and type mismatches earlier by essentially running the compiler. And of course, with TypeScript, you have built-in integration in VS Code. The same goes, I think, for Go, since I used it a couple of years ago. And so you get this sort of shorter feedback loop, which is, I think, the common thread to a lot of these practices that I mentioned here. And so shorter feedback loops are not a new idea. It's, in fact, one of the cornerstones of agile development, and it really applies to many stages of the software development lifecycle. And let's start with a definition of what a feedback loop is. So a feedback loop could be defined as the process in which an action's effect circles back to the action that triggered it and then used as feedback. For example, you push a git commit, into continuous integration pipeline starts, and that either passes or not. And when it doesn't pass, it contains useful feedback about what failed. And feedback loops are everywhere in software development, because essentially as a developer, as a team, or even as a company, you're engaging in this iterative process of creation through experimentation. And feedback is so essential because that's how you verify the assumptions, whether those are product assumptions or technical assumptions about, the domain logic that you're implementing in your application. And so feedback loops vary in terms of the amount of time from the action to the feedback. And for example, unit tests are usually very quick to run, whereas end-to-end tests take longer. So the feedback loop is not quite as tight as the one that you get with something like unit tests. So let's see how this idea of feedback loops maps to type safety by comparing JavaScript and TypeScript. And so a type error and we'll start with what is a type error, actually. So a type error occurs when a value in an operation is of a different type from what the code expects. And so JavaScript is loosely typed and doesn't really support type safety. So for example, when you define the following function, this getFullName function, there are a couple of ways in which you can encounter a type error. For example, if you just call it without passing anything in, you will get an uncaught type error. And the main problem here is that you will only detect this type error by actually running the code, meaning that you'll only detect this at the runtime of the code. Now, if you pass an object that doesn't have one of the fields expected by the function, JavaScript won't even throw an error. Instead, it will convert this undefined to a string. And this is a feature known as implicit type coercion in JavaScript. And again, the problem with this is that you only detect these problems at runtime. And in this case, you might even miss it because there's no error being thrown due to the implicit type coercion. In other words, you either rely on your intuition or tests that actually run the code to verify these kind of errors. And so in late 2012, TypeScript came along and suddenly offered developers the following proposition. You add types to your JavaScript and we'll make life easier for you by catching errors for you. And so with TypeScript, you'll have to carry an umbrella, but when it rains, TypeScript will catch these type errors and keep you dry. And so you eliminate this whole class of errors. And TypeScript essentially works by adding type annotations or by defining these types. And by adding these type annotations, for example, here to the function parameters, you can statically verify calls with invalid parameters and many other type errors. And so here you essentially get a type error, and you get that immediately while you're writing the code, assuming that you're using an IDE that has integration. So with VS Code, you get the squiggly lines, And this brings us back to the idea of the feedback loops, because you get a very, very tight feedback loop. Because with VS Code, type errors show up as you type the code, thereby reducing and tightening that feedback loop even further. And of course, you can also run the TypeScript compiler in your terminal and then get the same errors, and even integrate that into your CI pipeline. This begs the question, how can we take this idea of type safety and then apply it to the popular three-tier architecture? The boundaries of web applications across 3 tiers, where you have the presentation layer that usually means the web client, or it can even mean just a native app, an iOS or an Android app. There's the application tier, which is where sort of your business, back-end business logic lives, and it does a lot of, it's responsible for sort of the coordination between user requests and the database, and of course, the data tier, which is the source of truth and where your data lives. Now, of course, this is assuming that you're building a data sort of an application that handles data and needs to store data. If you need to store data, like most applications today do, there's a very, very good chance that you're going to be using a database. And so, okay, that was the 3-tier architecture. But since most of the database interactions are encapsulated in the server, in the application tier, what would it look like to introduce type safety there? Let's go back to the code sample that we looked at before and see how this might work if we were to add type safety. And so let's say we wanted to take this function that finds a single user's document and then returns the first name and the last name. Assuming that we wanted to make this type safe, how could we do this? The getUser function first takes an object ID string and then returns a document or an object. This is a challenge because of MongoDB's flexible schema. And this is actually by design. So MongoDB's collections by default do not require their documents to have the same schema. This means that documents in a single collection do not have to have the same set of fields, and the data type for a field can differ across documents within a collection. So just imagine the example that we had Peter show us before, where you had this blog post collection, and that collection had, say, name, and it say it had first name, and then later you decide, I want to introduce last name. There's no way for you to guarantee that once you introduce that all of the old documents will have the last name. And sort of this becomes a real challenge with this flexible schema. If there's no consensus about what the data model should look like, and every document in your collection contains slightly different fields, you end up managing a lot of that complexity in your application layer. So what if we introduce a schema to ensure more consistency across documents in a collection? Which leads us to the second part of this talk, MongoDB and schemas. So there are a number of solutions that have addressed the challenges of a flexible schema, and of course this is by no means an exhaustive list, but these are the very common ones. The first is MongoDB schema validation, which makes it possible for you to enforce a schema per collection. The schema is defined using JSON schema, and it's enforced during updates and insertions. And this approach, of course, the moment that you introduce a schema validation in MongoDB, it only applies to future writes, which means it doesn't impact existing records in your collection. I believe this was also introduced in MongoDB version 3 at some point, and I believe that's sort of a testimony or a sort of a reinforcement to the idea that introducing schemas to MongoDB is an idea worth pursuing. The second approach is Mongoose. Mongoose is a Node.js object data modeling library. It's kind of like an ORM, but mostly targeted at MongoDB. And it allows you to essentially define and enforce this schema on the application layer. And finally, we have Prisma. Prisma is a next generation ORM for Node.js and TypeScript. And central to Prisma is this Prisma Schema, which is a human-readable data model. And it is, of course, also declarative, as we saw in Peter's example. And with Prisma, you essentially define the Prisma schema, and the type-safe client is generated for you. And recently we introduced, earlier this year, we introduced the early access version of the MongoDB connector. And in July, we also made a lot of progress and promoted that to preview, which is the state that it's currently in, which is the last stage before it reaches general availability, meaning that it is production ready. So, okay, I spoke about these three approaches to introducing a schema to MongoDB. How do these three compare? Well, MongoDB's schema validation is enforced on the database layer, whereas Mongoose and Prisma enforce the schema on the application layer. Now, if we compare Prisma and Mongoose, Prisma is unique in that it not only enforces a schema, but it provides type-safe access, which makes you more productive by shortening that feedback loop. So with Mongoose, you get this validation, the schema validation, but that happens at runtime. With schema, as you're actually, with Prisma, as you're actually writing your application code, you get that those type safety verifications happening for you immediately because it's relying on the TypeScript compiler. And so you get sort of, that's why the feedback loop is also shorter. And speaking of schemas, it's worth noting that conceptually speaking, schemas have a lot in common with types. And on the left here, we have a TypeScript type, and on the right, we have an equivalent JSON schema type. And it's interesting because we treat these two things as being different, but actually, as our host today and Peter might attest to, the word schema actually comes from the Greek word schema, which means shape. And so when we speak about schemas and types, really, we're speaking about shapes, and those shapes are used to describe shapes of data. Of course, this doesn't mean that they are the same. They typically operate on different levels. Types are validated during compilation and have no impact on the runtime, while JSON schema is a runtime validation that you do. And this important is difference because you can validate a lot more about the shape of data during runtime, because assuming you have input coming from, say, an API request, that's not something that you can necessarily verify using your type system, because the type system of TypeScript, say, doesn't run actually when your code is running. So Prisma, I spoke and I mentioned Prisma a bunch of times, and it's worth sort of like giving an overview of what Prisma is. So Prisma, as I mentioned, is a next generation ORM for TypeScript and Node.js, and it consists of three tools. The first one is Prisma Client, which is an auto-generated and type-safe database client. This is sort of generated for you based on the Prisma schema. You import that into your application, and then you can sort of start interacting with your database, writing, reading, manipulating, and deleting data. The second one is Prisma Migrate. Prisma Migrate is a declarative data modeling and a customizable migrations tool. And finally, Prisma Studio, which is a modern GUI to view and edit your data. Okay, so let's look at data modeling with Prisma Schema. The Prisma Schema enables easy and intuitive data modeling. I think I mentioned that, and it serves as a single source of truth for your application models. With MongoDB, each model maps to a collection. So each Prisma model maps to a MongoDB collection. And in this model, this example model that we have this ID field, which maps to the _ID, the default ID field in MongoDB. And we also have this @db.objectID to denote the type. This then allows us to verify that we're actually passing an object ID in Prisma Client. Then we have this first name of type string, last name, which is an optional string, and finally email, which is of type string and has this unique constraint added to it, a unique attribute. Now, That was one model, but what happens when you want to start introducing relationships? So here I extend that model and then I add an additional one. I add the post model, and what I'm defining is I'm defining a one-to-many relationship between user and post. So that means that a single user can have multiple posts. And it should be noted that Prisma will use references to model this relationship. Now, take a moment to look at this schema, because the examples that will follow will be based on this. Okay, so what are the benefits? Well, working with databases is still one of the most challenging areas of application development. If you consider data modeling, schema migrations, writing database queries, these are common tasks that you have to deal with on a day-to-day basis as a developer. And as tools become more specialized, application developers should be able to focus on implementing value-adding features to their organizations instead of spending time plumbing together these layers of application by writing a lot of glue code. And so the core benefits of Prisma are productivity through shorter feedback loops with rich auto-completion and less boilerplate. And second, confidence, type-safe database queries that can be validated at compile time. And these two pillars are embedded into Prisma's workflows and API. So let's take a look at what Prisma Client looks like. So here I am showing a Prisma Client query that creates a document in the user collection. And I spoke about these two benefits before, productivity and confidence, but how does actually Prisma achieve this? Well, first thing is auto-completion in code editors instead of needing to look up documentation. You see that as I do the control space to show the allowed fields, I really can know what data I can actually persist in this, pass into this query. And as you can see here, I'm also passing an invalid field that isn't in the Prisma schema, and I immediately get this type error. Prisma also focuses on queries rather than classes to avoid these complex model objects that are very common in active record ORMs. Prisma Client simply exposes methods that return plain old objects. Prisma Schema is the single source of truth for both your database schema and your application models. You get this type safety and, of course, less boilerplate so that you can really focus on the important part of your application. And so working with relationships is also quite a tricky part, and the nested API in Prisma Client makes it easy for you to reason about storing related data. And so in this example, we create one document in the user collection and two documents in the posts collection with a reference to that user who created. And we can see that because on the right-hand side, you may notice that the author ID is pointing to the same ID in the root object of the user. And so let's take a look at what that looks like in the database. And so that same query, if you look at it through MongoDB Compass, the sort of the MongoDB database GUI, which is more or less equivalent to what Prisma Studio does. You can also use Prisma Studio. You can already see how these are created. And here too, when you are working with an object that you created in the database, you still get the same degree of type safety when you're trying to access the data that was returned, the object that was returned from the Prisma Client query to MongoDB. And you have this, again, this full auto-completion. And this is done by really leveraging a lot of the functionality that the TypeScript type system provides. And so that was that. And I think it was pretty cool. I mean, I've been working with Prisma for a while now, and so I'm kind of used to this developer experience. But it is pretty amazing to see this in action, and it is worth sort of asking, how does this all work, and how does Prisma achieve this? And really, it all starts with the Prisma schema, a single source of truth, as I mentioned, and it is used to generate Prisma Client, which you then import into your application code. And since Prisma introduces a schema, and obviously we're talking about how to stay productive while still introducing change, most of us developers are actually constantly changing whatever we're building, new assumptions, new features, bug fixes, and so on. And in many times, those involve changes to also your database schema or your data model and the information that you want to store in your database. For example, imagine from Peter's example before that you wanted to add a view count for each post. That would involve actually adding this new field to new documents that you're creating. And so how do you evolve this schema that you have when you're using Prisma? This is really where Prisma Migrate comes in, the declarative database migrations tool. And our vision at Prisma is to really enable developers to easily evolve their schema and manage database data migrations. We've already seen the great success of many developers using Prisma with relational databases, and we want to take a lot of those insights and apply them into MongoDB 2, of course, given all of the differences when working with MongoDB. And so introducing a schema to MongoDB poses a challenge because, as I touched on in the previous slide, how do you maintain that consistency across documents when you change the schema? For example, how do you add a new required field to a collection with existing data? This typically requires you to migrate existing documents so that they can adhere to the updated schema with this new required field. And there are several approaches to this. The first one is doing an all-at-once data migration, where essentially once you introduce the new feature, or even prior to that, you go to your database, you look at all of the existing documents and say you migrate them and add this new views field set to 0. There's also the on-demand approach, where you add a new field to your Prisma schema and then gradually update existing documents. And this is the approach also that Mongoose takes, and it's also possible with Prisma. So coming back again to the views, view count on posts example, assuming that you already have some posts in your collection in MongoDB and you want to introduce this new field, then you might want to sort of go and do a batch update to all of those, setting that to 0. That would be the all at once, and then doing it on demand would be every time you fetch it, you can either set a default, which means that the default will kick in and you will get 0 if it's not defined in the document, and then when you write it, it will get persisted in the next write to your database. Then you have the non-breaking change policy, where you essentially just introduce a policy in your continuous integration or whichever tooling you use to check, basically to only allow adding fields and never allowing changing or removing fields. And then finally, you have the final approach, the background integrity checks, which is an approach where you essentially run checks for consistency in the background. And then when an inconsistency is found, you either alert the developer to update the data, or you, based on the structure of the data you in that code, you decide, okay, how I want to migrate this. So you might just do a routine check to see which documents don't have the view count field, and the ones who don't, you just set it to 0. Now, in the last 2 years, a number of new frameworks have chosen Prisma as their default ORM. You have Redwood.js, which was created by the GitHub co-founder, Tom Preston Werner, and it is a full stack framework based on React and GraphQL. You have Blitz, which is a full stack framework based on React that also does away with the API layer, essentially giving you a way to make calls directly from your front end to back end without having to think about the whole API layer. You have Keystone.js, a headless CMS that also uses Prisma under the hood. Application, which is a toolset for building full stack apps based on React and Nest.js. And finally, Wasp, which is a DSL for developing full stack web apps with React. And so Prisma really is the result of the learnings that we've gathered from being an early innovator in the GraphQL ecosystems, and the insights we've gained into the data layers of many different companies, from small to mid-sized to even major enterprises. And as I reach the end of this talk, I'd like to share a bit more information about the current state of the MongoDB connector and also what you can expect in the near future. So since July 2021, a couple of months ago, I believe it was actually just a month ago, MongoDB support is now in preview, which means it's still not production ready, but it is already sort of started to stabilize. And there are a bunch of limitations that I thought are worth pointing out if you're planning to use Prisma with MongoDB. The first is that there's still no support for embedded documents that are typed. You can use embedded documents right now using just the JSON type in your Prisma schema, but we really want to enable developers to choose which data modeling approach they want to take. If you want to use references or if you want to do embedding. These are the sort of the two main approaches to data modeling in MongoDB. And so right now you can sort of use embedded documents using the JSON type, but in the very near future, and we already have a proposal that was published as part of the previous Prisma release about how you would be able to use the Prisma schema to type your embedded documents. There's also the second topic, which is indices. So currently you have to define an index directly in the database. And of course, our plan is to allow, as you define those, like if you add an @unique in your Prisma schema, that Prisma will automatically create those indices for you in the database. And then finally, adding Prisma to an existing project that uses MongoDB. And so as a big topic of the talk was how do you introduce a schema and how do you ensure consistency across documents? And when you want to introduce Prisma into an existing project, our current thinking is that you should be able to sort of have Prisma introspect your database and create, of course, populate the Prisma schema, but also create a feedback loop to inform you about all sorts of inconsistencies across documents in your MongoDB collection. And so we plan on moving really forward with all of these things, and this is also where you come in. So if you are interested in this, I would highly recommend you to check out the Prisma MongoDB connector and provide us feedback. And so that way we can address these quickly and bring the MongoDB connector to GA. And so just to sort of summarize today's talk, we looked at some of the practices that increase productivity as a developer by looking at type safety and feedback loops. We then looked at some of the parallels between types and schemas and explored the different solutions to having a schema in MongoDB. And finally, we looked at the confluence of these ideas in Prisma and how it enables you essentially to be more productive with your MongoDB database. And so on that note, I'm excited to invite you to try it out. You can do that at pris.ly/mongo. That will redirect you to our Getting Started guide. And with that, I'd like to thank you for listening, and I'd be happy to take any questions if you may have. We also have, I should point out, we also have some of these MongoDB Prisma stickers, and I'll find the link. If you're interested, we can send them to you for free. So that was that from me, and thank you once again.
Thank you very much for this talk. I really enjoyed it. I wanted to say a bit more about it, and I like the last slide where you have the journey for the Prisma and how it has evolved. I've been using it from version 1 where you had to have a GraphQL client, and then I was quite excited when I found out that you can just use the client directly with your code. You don't have to have another layer of the GraphQL layer. You don't need to actually learn GraphQL. You just straight write JavaScript or TypeScript to be more type safe. That's a cool thing about type safety. We can also bring Peter as well in the panel, so we can have like a small discussion between the three of us.
Certainly.
Yeah. So thank you both of you for this nice talk. I have one question before we start this conversation that came up. There are a lot of people that currently use different databases with Prisma. You can use SQLite. You can use other databases. how difficult will it be to migrate from another database to MongoDB with a new connector?
Yeah, that's a good question. I guess it really depends on which database you want to migrate from. In all of my experience, I've rarely encountered a situation in which a company just decides, oh yeah, we're going to switch from Postgres to MongoDB, no problem, because the tooling is just not being there to really allow for these kinds of things. And especially if you're dealing with companies and applications that really require a lot of require high availability and that they're constantly accepting traffic, this can be a real challenge. But if you are in a situation where you have the privilege of, say, shutting the application down, putting it in maintenance mode for a couple of hours, theoretically you could do a migration like that from one database to another. But on that note, I think it's also worth pointing out that usually, you pick a database very early when you start a project, and it's rare that you change it. And you usually pick that database for whatever reasons you had when you chose it. And so while it is possible to do these kinds of migrations, and really Prisma gives you a unified API where you essentially interact with one database and another more or less the same way, of course there's nuanced differences between how each of these work, then it should be possible. But in general, sort of MongoDB really encourages a lot of denormalization, whereas relational databases take the opposite approach, where they encourage you to normalize your data. And so while it is possible, I'm not sure how many people are actually facing this problem.
Yeah. No, it makes sense. Because the sort of big key thing about Prisma is that you can connect any database you want. You can do Postgres, you can do MongoDB, you can do SQLite. It's very easy to host your application in Heroku or Netlify or Vercel, I suppose. So yeah, it's environment friendly to any kind of environment. Yeah. Peter, do you have anything you would like to discuss or ask?
Yep, certainly. First of all, thank you, Daniel, for the great presentation. It was something that I really was looking forward to. Something that I would really like to add is that the inspiration that came from what you showcased about the different layers that an application involves. For example, the presentation layer, the application layer, and the database layer. Actually, I was really surprised. I was pleasantly surprised in the way that the typings that are generated from the Prisma client. Basically, if also you can see the showcase repo of our example application, the only types that exist across server, client, and also any code that has to do with data access layer, they are the types generated from Prisma. So for all the engineers out there trying to architect an application and want to have this let's say this type safety and the capability to minimize errors as much as possible, I consider that a superpower. Having the types, sharing them between the application layer and the database layer, which Prisma has let's say the full control of the objects and the entities that are flown from one side to the other, and even on the view layer side of things. For example, in my application, I used exactly the same types, and everything was great. So I consider the modern stack with TypeScript, typed interfaces, and all the great work that you have done on the MongoDB connector. It gives you superpowers. So yeah, congrats on that.
Thank you, Peter. Thank you also for sharing your perspective and giving the talk, really showing how this would be used in practice.
Yep, and actually this could have been just a showcase, But to be honest, in most of the, let's say, the companies that I've worked and the projects that I've undertaken from enterprise down to startup level, etc., the correct modeling and a reliance on these simple structures which flow across all the, let's say, the specific layers and let's say the APIs, the client interfaces of an application. This is what makes a product, let's say, less error prone, much more, let's say, testable, which is something that we haven't touched in this talk, but it's something of much importance, of great importance. And yeah, certainly this all starts with the main types of the entities that you have. So yeah, I'm really looking forward to what other stuff will be built with all this modern and next generation ORM that you're introducing there.
Yeah, likewise. I also think it's, we had a comment from someone who wrote tricky part, not connecting, but most likely migrating all the data from one database to the other, and I totally agree with that comment.
Yeah, the cool thing about Clerk and Prisma is the speed, because most of us we have to create stuff quite quickly. The expectations for developers it has increased. There are too many projects to do, but there are not many developers, and that's what most of the clients find right now. So, as a front-end developer myself, the difficulty is that I don't know a lot about Node. I don't have to do all this kind of stuff that Prisma does for me. So just the only thing I need to do is to create all these endpoints and start using them straight away. And with migration, I think one of your slides that you shared with us is when you change something changes in the data, you are able to see that, right? Could you tell us a bit more about that and explain how that will be quite beneficial for the front end developers themselves? How much time they would save?
Absolutely, yeah. I think it's maybe worth starting with, say, relational databases, because that's where these kinds of migrations are really something that you plan in advance. The whole point, with MongoDB is that you have this loose schema. So, assuming you're using a relational database and you wanted to add a new field or a new column, so to say, and I think I can give the example of, say, you have a user model and you have a post model. They have a one-to-many relation between the two, and you want to now introduce a new field to the post model, and that is a view count. So how would you approach this with a relational database, and what does that mean for you as a front-end developer? The first thing is, how would you introduce this change? Well, the first question you have to ask is, do you want this to be a required field? I generally lean on making something optional only when it actually is absolutely optional. The moment that you make too many things optional, you create too many variants. So unless you absolutely need it to be optional, I will usually introduce a new field as something that is required. And that obviously poses a challenge, because what do you do with the existing records that you have that don't have this? And so the general approach is you can use a default, once you introduce that to your Prisma schema, you run Prisma migrate dev. This is the part of Prisma migrate, which the command that generates the SQL migration for you. And when you create that, you can actually edit the SQL and define how you want this new field to impact existing users. Existing records or rows. And so you have the option of either setting the default, which will automatically apply to all of the existing ones that didn't have it, or you can actually manually go ahead and edit the SQL and modify existing documents based on whatever parameters and whatever logic you decide. The moment that you finish that, Prisma client is already generated for you, and you have access to that field. through the types, and you can sort of, if you're building an API, you can also send that through the API. If you're using something like GraphQL, you might want to say, oh, I want to introduce this to the post type in my GraphQL schema, and it will have, say, the type integer. And then the moment that it's in your GraphQL schema, of course, this really depends on how your front end interacts with the back end. But assuming that it's a GraphQL schema, then essentially you now have the option to query that field through your GraphQL schema, and then you can choose to use that in your front end. That is more or less sort of like the approach that you would take when introducing a new feature using Prisma and a GraphQL API. With REST, it's also more or less the same. You can just add the field to the API endpoint, and then it's up to the front end to decide how to use that field that it now receives in the same API call. Does that make sense?
Yep. Yeah, it sounds really cool. Yeah, it's some of these features that people maybe don't know, and when you know, it's like it saves a lot of time. Like that's the main kind of benefit. And yeah, definitely. What is the next features that they are coming up with Prisma? So that you are very excited about, because I think there are many, but some of them that you are very excited about.
Well, I should probably start with all of the preview features that hopefully will reach general availability in the very near future. And so one of those is obviously the MongoDB connector. There's also the SQL Server connector, which is going to be released to general availability. There's also some added Prisma client functionality, like the ability to order by relations. But one of the things I'm really, really excited about is I think Prisma has already gotten to the point where the Prisma client API is quite robust. And it really allows you almost the same flexibility that you would get with other ORMs, if not, I mean, the developer experience, in my opinion, is obviously better. And we've really played a lot of catch up in really providing all of this functionality that it now provides. And I think what will become really interesting is the Prisma Cloud product. So we're working on the Prisma Data Proxy. And the idea with the Prisma Data Proxy is that it will give you, it is part of the Prisma Cloud product that we're building right now. And the data proxy is going to make it a lot easier for developers who are using serverless to use Prisma with serverless, because one of the main challenges today for using a relational database with serverless, and irrespective if you're using Prisma or any other tool, is that a serverless function can only handle a single user connection. Unlike Node.js processes that can handle, their whole point is that they can handle multiple HTTP connections. So what actually happens, say if you deploy a Versal app that connects to a database, is that each time someone calls the API, a function starts and a function actually initiates a connection to the database in order to send the query. And why is this a problem? Well, you basically end up having as many connections to the database as you have user requests. This is with serverless, whereas with the more traditional Heroku kind of style where you deploy your app and you have a single instance that handles multiple requests, you have a single server that maintains an open connection to the database and can handle and multiplex multiple user requests. And why is this a problem with serverless? Well, databases, actually, it's quite expensive with most relational databases. To open up a new connection to the database. The first thing you have is TLS termination, which adds some overhead. But beyond that, actually, the database itself has to allocate resources in order to open up a connection to it. And so every time this happens, applications that use a relational database with serverless, they tend to suffer from a lot of performance problems. And so the general sort of approach to this problem has been to introduce something like a connection puller. But if you're using serverless, the whole point is that you want to avoid the operational overhead of deploying stuff to the cloud. So the moment that you have to suddenly introduce a connection puller like PG Bouncer, you actually eliminate sort of the benefit that you got from serverless, making you not have to worry about infrastructure. And so the idea with this, the Prisma data proxy is really to make it easy for any developer using Prisma with any of the supported databases really to get this free data proxy, which essentially solves this problem for you. This is only one part of the cloud product, and the vision is much broader. You can already today use the cloud product. You can go to cloud.prisma.io, and what you can do is you can create a new project. You can create a new Prisma project and also provision a database in Heroku. All of this is free and available. And you get sort of an online data explorer, and you can invite collaborators that can also view the data. And so I really think that sort of the future of Prisma really lies in sort of two facets. The first facet is really improving Prisma, the actual open source stuff, so that you can really have the full flexibility to do everything you want. And then the second thing is really adding some more functionality to the cloud product to really improve the workflows for mid-sized and even larger teams. But the sort of the grand vision is really that the Prisma together with the cloud product can really help you stay productive from the stage of being, a weekend indie hackers pirate all the way to becoming a large-scale company. So I hope that answers your question.
If you go that way, where is your data located? Is it in Prisma, in the Prisma Cloud, or is it in you can host somewhere else?
I mean, you fully control your database, so you can connect it to any supported database, or you can use the UI in order to provision a database on Heroku. You currently can do that. We don't own your database. We're just sort of sitting in the middle and just enabling a lot of the workflows around it and the connection pooling with the data proxy.
That's cool. Peter, do you have any question? Do you wanna?
Well, actually, this let's say what Daniel has explained, like sounds pretty excited. I've seen some similar solutions in more, let's say, closed provider spaces. For example, the Amazon RDS proxy, which does the thing, but it's internal to AWS. So I really consider, let's say, the case that you don't need to own the data, but provide this thing for the client. That's a great benefit. And certainly it pertains a whole slew of excellent technology there. And definitely the concept of Prisma becoming more like a place that you can, let's say, start as Daniel said, your pirate project up to, let's say, the enterprise requirements, and providing this cloud interface certainly would, let's say, because at least in my perspective, the Prisma developer experience is excellent. And I mean the actual in the trenches experience, not someone that a product manager would say, but as an engineer working with this product. And definitely the capability to become also something more, let's say, a collaborative tool in the cloud like Airtable is. I believe this is close to what's been teased here for like one feature set of the Prisma Cloud, if I'm not mistaken. I think that's a great space to be in. That would be it. I'm pretty excited for the features that are coming over. Really cool, Daniel.
Thank you very much. And I thought maybe if we have a couple of moments, I can quickly share my screen and maybe give a quick overview of the cloud platform, because you sort of like talked about Airtable and how it might compare, and I thought that if you'd be interested, I'd be happy to sort of give like a quick demo. Do we have time for that, Aris?
We have like 5-10 minutes max.
Yeah, I don't need that long even. So I'll just quickly share my screen here. So basically here I logged into the Prisma Cloud platform. again, either of you can just go ahead and try it out at cloud.prisma.io. And this is a project that I've already sort of, I have it deployed. I think it's deployed to Railway in a cloud platform. And basically here I can view my schema for this project. This is actually coming from the GitHub project. So if I open up GitHub, really this is just pulling it from here. And really the nice thing that I can do here is, first of all, I can invite users and give them different roles. So for example, I could give Peter some viewer access, which means he would be able to explore the data in the database without the ability to change it. And then we have the data browser, which is essentially a hosted version of Prisma Studio. And here really I'm directly interacting with my database. And so I can add records, there we go. And now it should reload in a moment. And there we go, we have it. And so, you know, you get all of this functionality. I can explore the relations, I can open them up. And really I have the full ability to access my data directly. So this is where it is right now. And the idea, then one of the next features will be to give you the ability to use the data proxy so that you can connect it through here. And also there's going to be a query console, which means that you'll be able to actually try out Prisma Client from within the browser and sort of like get a feel for the different queries, and you can do that against, you know, your real database. So these are some of the things, and of course, the onboarding flow. You know, you can, if you're really new to Prisma, you can just go to create new project. You can JS Monthly London. You can actually just create a new project. I'm going to provision a database. I hope that my Heroku account can handle this, because I think I've already created so many free databases on Heroku that I'm not sure it'll allow me to do that. Okay, I have to log in. So I won't do that now, but the idea is that it will provision a database for you. It will actually create the database schema from a bunch of samples that you can choose, and you can really like already get a feel for Prisma. So that's basically where the Prisma Cloud product is. And yeah, if anyone's interested, you can already check it out today. So that was it from my side. Thank you for the space to do this and to show it.
Great. I'll definitely check it out.
Yeah, no, that was really good. I like that. Because when I first tried Prisma version 2 on a hackathon, I had to do like a hack to upload to run the migrate function on Heroku, where this is like pretty straightforward to do. It's yeah. I'm laughing, but it's laughing from excitement. But yeah, it's amazing.
Good.
Okay, so yeah, I think we're gonna end it here, but it has been a really nice meetup. We did a bit more because we had so many questions from the hall. I think the guys at Cleric, they have in their roadmap also to do a Prisma integration. So it's quite exciting that we have you both on this meetup. And yeah, we have another meetup in 12 days. So we will have another like Prisma talk there. And yeah, I will see you all in the conference. I hope you can watch it online, or if you happens to pass by London, you can say hi and be there. But thank you very much for everything. And your talks are going to be going online, hopefully, and people can watch them later. Have a good day.
Thank you, Aris, and thank you, Peter.
Thanks.
All the best, and thank you to the viewers at home.
Thank
Bye,
you,
everyone.
Bye-bye.